this demo, we are going to build and install Aegis from the source code and use Aegis template transformations and an Aegis init container to interpolate secrets that are stored in Aegis safe onto Kubernetes secret objects. Well, that's a bit mouthful, but it will be much clearer when you see it in action. This video will introduce relatively advanced Aegis concepts to you, so it might be useful if you follow this link and read more about what Aegis is, Aegis concepts, and its building blocks and components before proceeding here. And also, if you haven't already done so, you might want to watch the video on this link for a brief introduction on how various Aegis components fit together. Having said that, let's begin. I'll be using an Ubuntu Kinetic instance as my working environment, but for macOS or Windows or any other Linux, you should be good to go if you can set up Minikube with a local Docker registry on it. And for that, there are OS-specific instructions depending on your operating system that you might want to follow this link to check out yourself. But as I said, I'll be using an Ubuntu instance to test Aegis on it. And if you are following along, you'll also need git and make installed on your system to replicate what I'll be typing on the command line. And I think that should be pretty much all you need for this demo at least. So this is my workspace directory structure where I have Aegis and its sister projects cloned in here. I'll first cd into this Aegis folder and execute make pull to pull the recent changes from the remote origins. And once that's done, we'll execute make start k8s to start our local Minikube cluster, and this will both initialize Minikube and also start the Minikube registry plugin so that we can use it as a local registry while building, packaging, bundling, and testing Aegis components locally. Then I'll run make sync to fetch the recent Kubernetes deployment manifest from the related folders into this Aegis folder. And next, let's do a git status to make sure that we have the latest code. And yes, we do. Our branch is still up to date. So now we can build it. To build Aegis and all the other dependencies, we'll do a make build local. And that will build Aegis components locally on our development machine. And this operation will build the code, containerize it, and push those containers to the local Minikube repository. And that's done. Next, we are going to execute make deploy local to deploy what we have built to our local Kubernetes cluster as well. And that's done, so we should have Aegis deployed and installed on our Minikube cluster. So to test it, I'll do a kubectl getpo-n Aegis system to check if our Aegis installation is up and running. And yes, it is, and our pods are healthy and up. And to make extra sure, I'll check the logs of Aegis safe. And the logs look just fine as well, so I think we can proceed and deploy a workload to our system and share secrets and have fun. Next, I'm going to deploy a workload to test everything end to end, and in this particular demo, I'm going to deploy a demo workload that utilizes Aegis init container to wait until a secret is registered to the workload. Again, seeing it in action is better than telling it, so let's cd into this demo folder and see what we have as a demo workload. So we have this main go file that has our application code, and there is a Docker file that containerizes our application, and there is this k8s folder that contains some deployment manifests. So it's a typical cloud native workload, so to speak. So let's look at our main go file first. There is some OS term signal handling here to gracefully shut down the application, but the more important part of the code is down below, where we display the values of several environment variables every 5 seconds in a loop. And that's our entire application code. So how do we get these environment variables? We'll later see that these environment variables are bound to our application by interpolating the data values of a Kubernetes secret. So let's dive into our Kubernetes folder to see how we deploy things. So this identity YAML creates a SPIFFE verifiable identity document, or SVID in short, for our workload. Again, you can check out these links for more information about what SVIDs are. But essentially, this is a way to give our workload an identity that Aegis can understand. So now let's check our Kubernetes secret. The strange thing about our secret object is it doesn't have any data section. That is to say, our Kubernetes secret does not contain any secrets in it. That's weird. So how do we add values? How do we add secrets into this secret object? Well, we will dynamically populate the secret at runtime through Aegis Sentinel, but there is this chicken or the egg problem here. Our application uses environment variables to inject secrets into its environment, and those environment variables are bound to the application during the container's initialization time, and they never change and you cannot modify it at runtime because they are in memory. So for our application to consume these secrets, they have to exist before the application has started. Luckily, Kubernetes has a construct to make sure that a container does not initialize until a certain condition is satisfied, and that construct is called init containers. And Aegis has a special init container just for a similar purpose, that you can use it to listen to the Aegis safe and let the main container start only after a secret associated with the workload has been registered. So let's see how we bind the init container to our workload by looking at this deployment YAML. So these are our bound secret values that are associated with our secret. Oh, by the way, this naming is important. For Aegis to recognize and identify and populate our secrets, its name has to start with Aegis secret dash, and it has to contain the name of our workload that we define in the cluster SPIFFE ID YAML that we have seen a while ago. And on the right, you can see the secret YAML descriptor again. And here is this init container that we will use to ensure that the main container here initializes only after an Aegis managed secret is bound to our workload. So if we check the makefile in the project root, there is this all local task that builds and containerizes the application, publishes it to the local Docker registry, and then deploys it to the cluster. So that's all we need, I guess. So I'm crossing my fingers and running it. Make all local. And we have deployed our workload now. And when we do a kubectl getpo, we'll see that our pod is still initializing because you remember the init container? It is waiting for an Aegis secret to be registered to our workload. So how we are going to register the secret? Well, there is this hack register sh utility script that we can use. So let's first see what we have in that script. So here we find where our Aegis Sentinel pod is. We extract the name of our Sentinel pod. Then we execute this command on the Sentinel pod to register the secret here to the workload here. And while we do that, we'll also do a template transformation with this -t flag to interpolate our secret, which is this JSON string, into a Kubernetes secret key value pair. And we use this -k flag to indicate that along with registering the secret to Aegis Safe, we intend to update an associated Kubernetes secret too. So let's execute this and see what happens. Hack register sh. And when I wait for a while and check the pod, I can see it is fully initialized now. And when I look at the logs of the pod, we can see that the pod displays the secret value that we just injected. And when we check the actual Kubernetes secret that's bound to the pod, you can see that it contains the data that we dynamically injected to it. Let's summarize what happened in a diagram. We executed this command in Aegis Sentinel to register a workload. With this -t, we asked it to also interpolate the registered secret into key value pairs. And with this -k flag, we said that we want to run this transformation to populate a Kubernetes secret. Then we first register the secret to Aegis Safe, and then interpolate the key value pairs of the secret through this transformation we defined onto the Kubernetes cluster. The main container in our workload has defined environment variables in its deployment manifest that points to these values associated with these keys on this secret that will eventually be populated. In addition, this Aegis init container, which is an init container in our pod, periodically checks Aegis Safe to make sure that a secret is registered to this workload before letting the main container initialize and start. And that's how everything is tied together. Before I forget, you can check the logs of Aegis Safe to have a glimpse of what's going on behind the scenes and maybe debug things when things don't work as expected. And before I finish, one final important note. Managing secrets this way is only recommended for legacy use cases where a tighter integration with Aegis Safe or Aegis Sidecar is not possible. Like, for example, you have a third-party container that you cannot modify its source code. However, whenever you can, consider using the Aegis SDK or Aegis Sidecar to directly talk to Aegis Safe to fetch the secrets. Why? Because a direct integration with Aegis Safe will have less moving parts and therefore it will be simpler to configure, manage and maintain. All good things. And you can check this link for a brief tutorial on how you can do that if you want. But as far as building Aegis from the source and interpolating Aegis managed secrets to Kubernetes secret objects goes, that's all there is to it. Hope you find this informative and see you in the upcoming videos.